Welcome you guys. So we're going to do 5.4. So we're going to do some properties of logarithms that are very important. We actually use the product, quotient, and power property in all the classes that follow. Well, maybe not in trig, but we use them for sure in calculus 1, calculus 2, differential equations, like all of those classes, you will see these properties again. Okay, so they're so important. And luckily, they're pretty easy to use, I think. And so that's the good news. Okay, so let's kind of look through these together. So what these are saying is that if you're taking the log of any base, well, it can't equal 1, right? But any other base, and there's multiplication happening inside. Well, that multiplication can split the 1 log into 2 logs and become addition. So kind of similarly, like if I probably didn't even tell you, if multiplication becomes addition, then you might even guess that if division's happening inside, that it would become subtraction. So I think these are kind of nice. Once you know one, the other one kind of makes sense. Okay. And then we have the power property, which says if there's a power, aka an exponent, that the exponent can pull to the front of the logarithm. And this, of course, works for any base besides 1. So this would be true of natural logs as well. Okay. So multiplication splits into addition, division splits into subtraction, and exponents on the argument of the logarithm can pull into the front. Okay. All right. So let's go ahead and try these. Okay. Use the product property to write the logarithm as a sum. Okay, so we actually have 3 times signs here, right? Like we have a multiplication sign between the 3 and the x, and a multiplication between the x and the y. So we're actually going to split this into 3 instead of into 2. If we go back to this property here, there was only 1 multiplication sign right here, and so that's why it only split into 2 logs. But in our case, since we have 3 things that are multiplying, we're going to split into 3 logs. So this is going to become log base 10 of 3 plus log base 10 of x plus log base 10, or the common logarithm of y. Okay, now it does say simplify if possible. Okay, so we have to ask ourselves anytime that there's a number, if we're able to actually simplify this. Okay, so the base on this is really base 10, right? And so what they mean by simplify it is this going to give you a nice number, like a whole number or an integer value, right? So remember we said to figure this out, we use the hook, we say 10 to what power equals 3? 10 to what power equals 3? Well, that's not going to be a nice number, right? It's clearly not going to be nice. It's going to be some decimal, right? So not an integer, not an integer. It will be a decimal. Okay. All right. So in that case, so don't do it. Just leave it as is. Okay. So leave as is. All right. Okay. So I'm going to go ahead and box what we have. Boom. Let's try the next one. So for the next one, the only difference, I mean, we still have the product property. So this is still going to split into addition. But the only difference is now we have the base 3. Log base 3 of 3. Log base 3 of x. Log base 3 of y. So you do have to carry the 3 for all of them. Okay, if you go back to that original statement of the theorem, if you have base b here, then when you split it, they still both need to be log base b. So you're going to have to carry that 3 around the whole time. Okay, but now when we ask ourselves if we can do this, we actually can't. So I'm just going to draw a little arrow to this guy. If we say we add an equals x and we say 3 to the what power equals 3? 3 to what power equals 3? We do get a nice number. We get 1, right? So we're going to go ahead and write one more line where we say 1 plus log base 3 of x plus log base 3 of y. So this one we actually could simplify and it gave us a nice number. So let's turn it into that, because who wants to look at this when they could just see a nice pretty one? All right, so let's go to C. So on C, the time sign's actually going to be right there, right? Between the 3 and the A plus B. So that's where we're going to split this log at and make it addition. So we're going to say natural log of 3 plus natural log of A plus B. Now let's talk about this, because a lot of students want to continue on, okay? But addition does not split. If you're taking the log of addition, it's nothing. Remember, we have the product property that says if you're taking the log of multiplication, you can split it. We have the quotient property, so if you're logging division, you can split it. It's not like there's a sum and a difference property. Okay, so we're not going to be able to split addition ever. We won't be able to split subtraction ever. Okay. Another thing people don't do is they forget the parentheses, but they're so important when you're doing addition and subtraction, because it tells, without the parentheses, if we have just, log of A plus B, then the only thing that's going to get the logarithm is the A. And then after you do that, you'll add the B. And that's not what we want in this case. We want the log to be acting on both. So the parentheses are super important. Now we couldn't continue on any further because E, if you remember, is a pretty gnarly number. It's like 2.7, blah, 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 blah. It goes on forever. So there's not going to be a power of E that's going to get you 3. That's going to be pretty, right? So we always ask ourselves, okay, let's write this out. The base is E, you add your equals X. E to the what power equals 3? Well, that's not going to be anything nice, okay? So in that case, we just leave it alone. All right, moving right along. Use the quotient property. All right, so we know that if multiplication becomes addition, then division is going to become subtraction. So we're going to have log base 8 of the top minus log base 8 of the bottom. So it's always going to be top minus bottom. All right, and then we have to ask ourselves if we can continue. So we're going to take a look at this guy down here. If we have log base 8 of 64 and we add our equals X, that means 8 to the what power gets you 64. 8 to the what power gets you 64. And maybe you can see that the answer would be 2, because 8 squared is 64. So then we can rewrite this. It became a nice integer value. It's not some decimal that's going to make it uglier than it is. Then we're going to go ahead and write a -2 here to replace that entire logarithm. Okay. Part B. Log base 8 of the top minus log base 8 of the bottom. Now this one's just here to fool you. It is. It's checking to see if you will write like a 3 or no 2 for that last number, because people will see the 8 and the 16 and they'll think that they should put 2. But if we go in here and we inspect that, right? We go in and inspect that log base 8 of 16, we add our equals X. 8 to what power equals 16? Well, there's not going to be a nice integer value for that, because we know 8 to the first is 8. 8 to the second's already up to 64. So it's got to be 1 point something. So it's going to be a decimal, right? So that means we're just going to leave it alone. Okay, we're just going to box it as is, you guys. We only do it if it becomes a nice integer value. All right, let's try this last one. All right, so let's see here. We have division. So by the quotient property, it's going to be log of the top minus log of, don't forget parentheses, the bottom. And then you have to remember what the base is when I have log and I don't write it. So hopefully you're remembering that the base, when I don't write any base and it's log, that the base is 10. So this first one is doable. We add our equals X and we do the hook method. 10 to what power gets you 1,000? Well, there's 1, 2, 3 zeros. So it must be 10 to the third. So we're going to continue on this one and go one more step. We're going to say 3 minus log of parentheses A plus B. So simplify if possible. All right, so we've used them all except for the power property. So let's get into that one. All right, so the power property is pretty easy, not a lot to do. Remember that the power shoots to the front. So we're going to shoot this 3 to the very front of the natural logarithm. So we have 3 natural log of x. Same thing could happen here. There's like 2 ways you could do this. You could say, okay, I'm going to put the 3 in the front. So we've got 3 natural log of e. And the natural log of e is actually the number 1. And so that's what gets us 3 for this. Earlier, you might have heard me in the last lesson say, anytime you see natural log and e together, they cancel each other out because they're inverse operations. And so that will just leave you the 3. If you know that, you can go right to the answer of 3 without having to do all those in-between steps, okay? So natural log and e will cancel each other out and leave you with just the 3, okay? All right. Now, anytime that you see in this chapter, a radical, you're always going to be rewriting the radical as a fractional exponent. Just make sure you do that like right away in these, okay? So I'm going to write that down because I feel like that's so important, okay? In this chapter, you will want to rewrite any radical as a fractional exponent. Okay. So we're going to go in here and we're going to rewrite this as a fractional exponent. So this is going to be log of x to the 2/3 powers. I'm trying to think, I think I brought this up in class in our lectures and stuff, but it's so rare that like it probably seems like this is brand new, you guys. But basically, I was observing a teacher once when I was a high school teacher, and they said something that I thought was kind of a helpful way to remember it. They said a plant's roots grow in the ground. So if you consider the fraction bar as like the ground, then the root should be in the bottom. And notice it is a cube root, so the root's going to go in the bottom below the ground, okay? So I'm just going to write that over or type that over here. Plants' roots grow in the ground. So make sure the root's in the bottom. Make this bigger. Oh my goodness. I'm over here on the edge, huh? Okay. I'll move it over. So that's going to have to do. I guess I can shrink the whole thing. So let me shrink it a little bit. There we go. Okay, so we're going to rewrite any radicals to make them fractional exponents. And the reason why is we want to use this power rule. So now that we have a power, we can pull it to the front. So we're going to have 2/3 in front of our log of x. Okay. So not too shabby. I mean, this last one was a little tricky with that rewrite, but just know that the root was in the bottom. But yeah, you're just pulling the exponent out front. Nice and easy. Love it. As a side note, the power property actually is a direct consequence of the power rule. So for example, we already know that if we have log of x cubed, that we can write that x cubed as x times x times x. Well, that's totally a product property, right? So multiplication becomes addition. So we got log of x plus log of x plus log of x. And when you're adding, you only add the numbers in front. All these ones in front are going to get added together. It's kind of like if you added root x plus root x plus root x or something, you would get 3 root x. It's along that same line, those same lines, okay? So we're going to add the ones in the front, and that's what gets us 3 log of x. So notice, where did the 3 go? It just went to the front in the very end, okay? I'll just title this the power property is a consequence of the product property. Okay. Consequence. Almost seems like there should be a W there. Okay. The power property is a consequence of the, get some more room here, product property. All right. So now we're going to put it all together. We're going to progressively get harder and harder till we work our way up to some pretty complicated logarithms. Okay. But so basically any one of those three properties is gain now. It's like, okay, am I splitting the multiplication into addition? Am I splitting the division into subtraction? Am I moving exponents out front? Okay. So the first thing that I'm going to take care of is the fact that I see division happening, right? We got division happening right there. Okay. And so I'm going to go ahead and make it subtraction. So it's going to become log base 4 of the top minus log base 4 of the bottom. Then we'll take care of the fact that we have multiplication happening right here, right? So since it's multiplying, we're going to split the multiplication into, hopefully you're finishing my sentence for me. So we're going to split the multiplication into addition. And we'll just bring down everything else unchanged. Now you're still supposed to simplify if possible. That's just like an always with this, okay? And you might remember in the last homework that whenever we see that these match, the base matches the argument, then it's going to become a 1. But we can go through the motions again for how to find it, right? So we'll add our equals x. This is like saying 4 to what power gets you 4? 4 to what power gets you 4? Well, x would have to be 1, okay? But hopefully in the future, you're starting to realize that when those match, you can just go right to a 1. So I'm going to go ahead and put 1 plus log base 4x minus log base 4y. All right. There we go. All right, we're going to start off very much in the same way. We have division happening. Oops, I don't know what I just did. Oh, I still have the square on. Okay, so we have division. So we know that the division is going to become subtraction. Base 5, log base 5 of 40. Now we have a lot of multiplication going on. I'm just going to put mult, and I'm going to put an arrow right there and right there. So we know that multiplication becomes addition. So we're going to split this log base 5 of AB into log base 5 of A plus log base 5 of B. Same thing's going to happen, but we need to have, this is tricky, parentheses, because we're subtracting away all of this. So we've got log base 5 of 4 plus log base 5 of D. Now, when that negative distributes in, it's actually going to change the sign on that last log. So that's why it's so important that you remember the parentheses, you guys. Now, I'll actually show you how I do it, because I don't actually myself do it this way. So maybe we'll run through a couple, or how I think about it, just to get the answer fast. I know you guys want the answer fast. We got a lot of homework, you know. So basically, the way that it works out is anything in the top is going to have pluses, and anything in the bottom is going to have minuses in front of it. So the A and the B, they're both positive. This is a positive. We don't write the plus out front, but it's just implied that it's positive. And there's a positive here. And then the 4 and the D are in the bottom. Okay, so a minus goes in front of that, and a minus goes in front of that. So let's just, I'll make up one on the fly here that's kind of got a lot going on. If we had 3xy over like AB, for example, right? Then we would have all the things in the top would be pluses. Log base 2 of 3 plus. Log base 2 of x plus. Log base 2 of y. And then anything in the bottom would have some minuses. So minus log base 2 of a minus log base 2 of b. We can go in one shot. We don't have to do this in-betweener step, or these in-betweener 2 steps, right? We went from the original problem to the final answer because we just knew all the tops would be pluses and all the bottoms would be minuses. Okay, so I'll just label this extra example. There we go. All right, let's try the next one. Okay, so I see some multiplication. So I'm going to go ahead and split this right where the multiplication is. So right between the x squared and the y. So this will become natural log of x squared plus natural log y. And we've got to do everything we possibly can. So we still have one more property we can apply. We did the product, but now let's do the power. And let's bring that power to the front. There we go. All right, so I remember me a couple slides back saying whenever you see a radical, start by rewriting that radical as a fractional exponent. So remember, the root goes in the ground. So the 4 is going to be the one that goes in the denominator, not the 3. Okay. All right, so we're going to say, all right, we got division. So let's go ahead and make this subtraction, right? All right, so this is going to become natural log of the top minus natural log of the bottom. And then we're going to go ahead and apply the power property to pull the 3/4 to the front. You keep going until you can't use the power of the product or the quotient property. That's when you'll know where you can't simplify anymore, that you're done. There we go. Too shabby. All right. Example 5. Well, here we go again. I'm glad we're getting a chance to practice this because I told you it happens so rarely that we tend to forget, at least in algebra, that we can rewrite radicals as fractional exponents. Once you've passed calculus, you never forget because you do that all the time. But at this stage, you often shows up so rarely that it's like, oh yeah, I forgot I can do that. So we're going to take this square root. Remember, there's a little 2 for the index that they don't write. Okay, but that's gonna be our root. So that's what's going to go in the denominator is a 2. You might be saying, well, then what goes in the numerator? In that case, if there's no exponent already there, then it would be a 1. Unlike the last one, like let's go revisit the last one because just to compare the two. There was already an exponent of 3 there. Okay, so that's going to be the top. It's the root that's going to go below it. If there wouldn't have been a 3 here, then we would have had to have put a 1 in the numerator. And that's the case here on our problem. All of this 4x divided by yz to the third has 1 as its exponent. And so that's why we're putting it all underneath a 1. Okay. All right, so we're going to power property this. We're actually going to do that first. We got to get this 1/2 exponent out of here before we can do the quotient rule, before we can take care of the division. Okay, so yes, we're going to totally take care of the division. So it's going to be, it's going to be 1/2 log base 2 of the top minus 1/2 log base 2 of, you know what, we should just use, hold on, let's see if we can handle this, you guys. Let's see if you can handle my method where we just go to the final answer, okay? Remember we said anything in the top will be positive and anything in the bottom will be minus, okay? So I'm going to go ahead and say, okay, then log base 2 of 4 plus 1/2 log base 2 of x. And now I've taken care of the whole numerator, so it's going to be minus 1/2 log base 2 of y and another minus 1/2 log base 2 of z cubed. Okay, so hopefully that kind of made sense. Something I want to point out, if you're not sure if you're like, should I have the 1/2 or not? Go back to the original problem and say, was it under the square root? If it was under the square root, then it should have the 1/2. And all of these were under the square root. So all of them should have the 1/2. If the problem were written differently and it was like this, well, okay, the y and the z aren't raised to the 1/2 power, right? They aren't under the square root. So they're not going to have a 1/2 in front of them. Only the things that are underneath that radical will get that 1/2, that fractional exponent. Okay. All right. Now we can actually continue on one of these. So hopefully you're kind of spotting which one of these we could keep going on. I'm going to take a look at the log base 2 of 4 piece, this very first one. Okay. We put our equals x and we do the hook property. This is 2 to what power gets us 4? 2 to what power gets us 4? And so hopefully you can see that that would just be 2. So we're going to go ahead and we're going to have 1/2 multiplied by a 2 plus all this stuff. Now there's more that we can do too besides just that. This 3 is going to go to the front and go right here with multiplication. So we're going to have that 3 multiplying by that 1/2. So if we put a 1 underneath the 3 and we multiply straight across, we're going to get 3/2 for being our new front number, our new coefficient on this last term. So I don't write it. All right, 3/2 is going to be the new coefficient. All right, so the last thing left is to just take care of 1/2 of 2, right? So 1/2 of 2 is 1. I told you guys we were going to work up to some pretty complex ones, right? Well, this one had a lot going on it. It's a very interesting logarithm problem. Okay. Holy moly. Okay, so let's see here. We know anything in the top is going to be plus. So this is going to be log base 8 of 64. It's going to be plus in front of it, right? So I'm talking about in front of the log. All right, and then it's going to be plus. The next thing is an x squared. So log base 8 of x squared. And then plus again, log base 8 of y. Now all the stuff in the bottom is going to be subtraction. So we're going to have minus log base 8 of 3 minus log base 8 of z minus log base 8 of w cubed. Now, we do have 2 constants in here. We got 64 and we've got 3. Only one of them is going to simplify. There isn't any exponent that we could put on 8 to get 3, right? I mean, as you're going through, the 8 to the first is 8, 8 to the second is 64. We kind of hopped over, 8 to the 0 is 1. We kind of hopped over 3. There's no 3 in here, so that means this would be a decimal value, right? It's going to be in between 0 and 1, so point something, right? All right, so that one we're not going to touch, but the one over here, well, you could probably see that it's going to become a 2, right? We took it off to the side and we did it the way we've been doing it just for consistency purposes. We add the equal x and we say 8 to what power equals 64? 8 to what power equals 64? Well, we already saw earlier that it would be the power of 2. So that's one thing that we can clean up. The next thing is you're probably noticing there's a lot of exponents that could go to the front. So let's do that as well. Let's use that power property. So this is going to be plus 2 log base a to x, log base a to y, log base a to 3, log base a to z, and minus 3 log base 8 w. I'm intentionally reading these out loud because I found that when students talk with each other, they'll look at it, but they don't quite know how to say it, And so if I just keep saying it over and over, log base 8 of, then maybe it'll just become something kind of natural for you. You can talk with other people about these problems. All right. Write the logarithmic expression as a single logarithm with coefficient of 1 and simplify as much as possible. So this is us using these in reverse. So let's go back to that very first page so you can see what I mean by we're going to use them in reverse. What's been happening is we've been given multiplication, division, and an exponent, and we've turned them into these on the right. But now what we're saying is we're going to give you these things on the right, and we want you to take the 2 logs and express it as a single log, right? So we want to take the addition, subtraction, and condense it down to multiplication and division. And instead of the p being in front, this is going to feel weird, putting it back into the exponent to get this, okay? So it's the reverse, basically, of what we've been doing the other direction. It's for some reason, it's so hard to go the other way. You get so good at one way, and then it's like, oh man, I got to reverse it. And it just messes with the brain just enough, yeah. All right, so we know that division splits into subtraction. So subtraction must condense back into division. So we're going to write these 2 logs as a single logarithm. All right, so we know it's top. The first one goes on top and that the second one goes on bottom. And if you're only good one way, then you can always check this the other way to see if it makes sense to you, right? We know it's going to be positive for the 4x minus 3, and it's going to be minus for the x. I don't think there's anything else we can do. So that's going to be our answer on that one. They always kind of start them off nice and easy for us. Thank goodness, right? Okay. Addition. Well, first of all, numbers in front were exponents. So let's put it back into the exponent. All right, and then plus, that's going to become multiplication, right? Okay, so addition will become multiplication. It's going to be a single log. Log base 2 of z times y to the 4th. And we're done. Now, one thing to remember is we'll always go from 2 logs to 1 log or 1 log to 2 logs. We'll never go 2 to 2. So if like for example, let's say that we take a look at A. One of the mistakes that I get from students is they'll be like, oh, subtraction is division. And so they'll write this. And I'm going to tell you, if you just know this trick that it's never 2 logs to 2 logs, you'll catch yourself. Like this person knew it was division, but the problem is it started off with 2 logs and it ended with 2 logs. It's always going to go from 2 to 1 or from 1 to 2. It'll never go 2 to 2, okay? So just think about that as you're going through and you're looking at your final answers. It's like Mecklenburg said, it started off with 2, better end with 1, right? Okay, so let me go box this. All right, example 5. All right, so we're going to go ahead and take the exponents, take the numbers out front and make them exponents. So this is going to be natural log of x to the 3rd. All right, so we know that anything that has a plus that's positive in the front, like these two, is going to go in the numerator. And anything that has a minus in front of it will go in the denominator. So the final answer should be this. Sorry, my kids are so loud. I'm not sure how much you can hear that. So this is my claim for the final answer. But if you want to like go in steps, then you could always say, okay, we know that addition is going to become multiplication. So you could turn these 2 logs into 1 log. And then you could go in and say, oh, okay, well, I know that subtraction is going to become division. And then we would end up with this answer down here. Okay. That one trick, though, sure helps, huh? Look at all the work it saved us. If you can just remember all of the things that are adding will be in the top and all the things that are subtracting will be in the bottom. It does make it go a little bit faster. Okay, we're going to shove that number out front back into the exponent eventually. The only problem here is, let's do some rewriting first, okay? Remember how we said, anytime you have a radical, you always want to start off by rewriting that radical as a fractional exponent. And remember that the radical, the root, right? The root is going to be, a plant's root grows in the ground. So the root's going to be in the bottom. So here's the 1 that's the current exponent, but we're going to put the 3 below it. Plant's roots grow in the ground. Okay, so now when we move this 3 up to join the 1/3, they're going to multiply. Boy, that's sure ugly looking. Let me put it right here so we can see it better. So those two are going to multiply by each other, right? So 3 is going to multiply by 1/3. So if we put a 1 underneath, we just get 3/3, which is just 1. So basically, they're going to cancel each other out. You could think of it as 1's in the numerator and 1's in the denominator. Okay. So that's going to give us natural log of x cubed minus just the natural log of x. Okay. And then subtraction is going to become division. So we're going to go ahead and make this a single logarithm with the x cubed on top of the x. And of course, we're not going to leave that. The directions say simplify as much as possible. So we're going to go ahead and cancel. Remember, x cubed over x. If you've got 3 x's in the top and 1 x in the bottom, when you cancel, you'll just be left with x squared, okay? Oh, another quick trick is to just subtract, right? If you do 3 minus 1, boom, you get to your 2. Oh my. Okay, they upped the difficulty here, huh? Okay, so let's stare at it for a bit, see if you can think about what you might do first. I wanted to kind of give you a chance to do that on your own before I just go feeding it to you, you know? And this one's actually kind of tricky because I bet a lot of you said I would put the -2 into the exponent, and you can totally do that. But let me just say that that's going to make things pretty gnarly looking, because that's going to give us this, which we're going to have to deal with. Like, what does that mean? We're going to have a lot of work because we're going to have fractions. So I have a quick fix for that. When we've been looking at stuff all this video long, right? All the minuses have been at the back end. You go back to some of our examples, like all the subtraction has been at the back end. It's been the last part of it, right? Go back to a couple others. There's my minus on the back end. So why don't we just do some rearranging where we say, you know what, I'm going to pick up this entire term. I'm going to shove it back here in the back, and just this simple rewrite makes this problem go so much more smoothly. So my advice for you is, if you see a minus in the front, why don't you just move it into the back? And then we won't have to do the negative exponent bit. Okay. All right, let me get this little piece out of there. Okay. All right, so in other words, instead of taking the -2, now we can take just the 2 and make it the exponent. Cool. Okay, and now we're looking pretty good because we know that both of these are positive logs, so they'll be in the top. And this is the one that has the minus in front of it, so it's going to be in the bottom. So we can write this as a single logarithm. It's going to be pretty gnarly looking, but here we go. We got an x and an x squared minus 25 that are going to go on the top. And then we've got an x plus 5 squared that's going to go in the bottom, since that one has a minus in front. Now it says to simplify as much as possible, and maybe you're spotting something, maybe you're not. But if your factoring is pretty good, then you're looking at that x squared minus 25 and you're thinking, I recognize that. That's a difference of squares. That's going to be x plus 5, x minus 5, right? So we're going to go ahead and write it as x plus 5, x minus 5. And then I might write this way, so it might be the easiest way to explain it. I'm not sure, but x plus 5 squared means x plus 5 times itself. Okay. So we can go ahead and cross off an x plus 5 from the numerator and an x plus 5 from the denominator. So now the most simplified that we could get this down to, and who knows if like they actually distribute the x in or whatever. I'm sure if you're on my math lab or whatever program you're using, that they'll accept it this way. That'd be my guess. Okay. Wow, they sure upped the difficulty on that one. So just to kind of recap, the best decision was to move this guy to the back end so that the minus is in the back. And then I don't have to put the -2 as the exponent. I can put the +2 as the exponent and then just know that this is division. So the stuff's going to go in the bottom. I think that's going to be the quickest way to get it done. And then this sneaky difference of squares in here, right? Now, that's a great actually segue into what we're going to do next. Now, this section, it's not in your textbook, which I couldn't even find it when I went to the index. So that tells me that they're assuming that you got this in a previous math class. Now, with my experience, you know, from teaching in college algebra for a long time, is a lot of people have never seen this before when they come into my class. So I'm going to make the assumption that this is actually new to a lot of you, okay? But I've noticed they give a ton of problems on the homework that use this. And we use this in calculus a lot too. I mean, I think week 1, we start off with limits and we have some with sums and difference of cubes. So I feel compelled to show you it. And I will assign some homework problems that have this in it. So just to fast forward so you can see what I mean. Hold on, let me get there. They have a logarithm that has a difference of cubes right here in it on your homework, right? And so I just want to make sure that you would know how to handle that, because this book's notorious for giving you problems on stuff they haven't taught yet. So I would consider this to be one of those cases. So we'll just do a little, hey, let's slide this in now, okay? All right, so we know that there's a difference of squares. The technical formula for it is this, and this just reminds you that this is called a difference of squares because subtraction, the word for subtraction is difference, and these are both perfect squares. So that's why this formula is called the difference of squares. There is no sum of squares. Okay, so no sum of squares. So if you see a squared plus b squared, like if you see something like this, don't do anything because that's not going to break down anymore. Okay, it's got to be subtraction, you guys. But when it comes down to cubes, we actually do have both a sum and difference of cubes. And so what that looks like, I mean, it should make sense. This one right here has a minus sign. So this is called the difference of cubes. This one down here has a plus sign. So this one's called the sum of cubes. Now, notice over here that all of the variables are the same. We got an a, we got a b, we got an a squared, ab, b squared. We got an a, we got a b, we got an a squared, ab, b squared. The only thing that's different is the signs. So that's where the SOAP acronym is really helpful, okay? The S of SOAP says that you're going to start off with the same sign. So let's say I'm looking at the difference of cubes one. Okay, its sign's a minus. Okay, then the first one's also going to be the same. Okay. Then the next one is the O, which is the opposite sign. So this one's going to be opposite the original. If this guy's a minus, this guy is a plus, right? And then the AP of SOAP is always plus. You'll notice the back end is always plus on both of these formulas. So it starts off same sign, opposite sign, always plus. If you go down here, same sign, it starts as a plus, it's going to be the same. Opposite sign, always plus. So when I'm doing these for myself, I'll write out the variables. I'll be like, okay, I know it's AB, A squared, AB, B squared. And then I'll just be like, okay, if it's a minus here, then I know it's the same sign, opposite sign, always plus. And it helps me fill in the at least the signs, but you got to put in the work to remember the variables. Okay. Soap. Hopefully you will remember soap. Okay. All right, so let's try to use this now. So when do we use this? Well, we use this when we see a sum or difference of cubes. So we might want to take some time to like write down some perfect cubes. Okay. So let's make a list of perfect cubes, you know, a decent list. Perfect cubes. Knowing these is helpful because you got to spot them. So 1 times 1 times 1 is 1. 2 times 2 is 4 times another 2 is 8. 4 times 4 is 16 times another 4, 64. 5 times 5 is 25. If you had 5 25s, you had 5 quarters, you'd have a buck 25, right? 6 times 6 times 6 is 216. 7 times 7 times 7, oh, is it 243? I gotta look, you guys. Let me go get my calculator out. I want to say it's 343, but 7 times 7 times 7, 343. And I don't even know 8 times 8, 9 times 9, so blah, blah, blah. 10 times 10 times 10 comes up a lot, though, because it's easy. 3 zeros, right? And then after that, who knows? Okay. All right, so these are the ones that show up the most often. In fact, probably not even the 343 very often. Okay, so if you know these first 5, the 1000, you're good. And speaking of, 1000's happening right now, okay? So the very first thing you want to do is you want to write this as a difference of cubes. So I'm going to rewrite it as 10 cubed. So now it looks exactly like the formula, right? I'll write the formula over here just so we have it to compare. Something squared minus something squared. We totally have that. Let me write it out. So the first one's going to be the same sign. The second is going to be the opposite. And the third is always plus. Okay. So now it's just a matter of filling in. I mean, hopefully that you can tell in our case, A is X. These are in the same position, right? And hopefully you can tell that B is going to be 10 because these are in the same position. All right, so now we're ready to go on in and fill in this. So this is going to become, if we're using the right-hand side, you guys, so the A minus B would be X minus 10. Then A squared, so that would just become X squared, plus A times B, so that's going to be X times 10, right? And then plus B squared, so plus 10 squared. And then you just clean it up, okay? So we got X minus 10, and then we got X squared plus 10X plus 100. Okay. All right. And that's it. The second portion will never factor this piece right here. So if you're like, oh, can it factor more? It never does, because if it did, they would have given you a formula where it was completely factored. And so this will not factor. This will be something you would have to use the quadratic formula to if you wanted to solve. Okay. Let's do a bunch more until we become pros, guys. All right, so we're going to start off by writing this as a sum of cubes. So if you recall, we said 4 to the third is 64. We look back at our list. So we're going to use the sum of cubes formula. So same sign, opposite sign, always plus. And in our case, A is X and B would be 4. The A cubed is the first number, and then the B cubed is the second number. All right, so we're going to go ahead and substitute these into the right-hand side of the formula, this side. So A plus B will become X plus 4. Then we have A squared, which would be X squared. And then A times B, and then plus B squared, so plus 4 squared. Okay, so this is going to become X squared minus 4X, and 4 times 4 is 16. All right. I'm doing a bunch. I mean, of course, if you're like, I got this and it was easy for you, you don't need this many. But I've noticed that from the past, that's taken quite a few before students kind of caught on. So I'm putting what I think would be enough for like the majority of people. Okay, so we're going to rewrite this as something cubed minus something cubed. Now this one's trickier than the others. So we have to write it as something cubed minus something cubed. So the cube root of 27 is 3. 3 times 3 times 3 is 27, right? We got 3 times 3, which would get us 9. And if we multiply it by another 3, there's your 27. Okay. All right, so this is going to be 3x then. The 3 times 3 times 3 is 27. The x times x times x is x cubed. All right, I don't know why I have a 1 here, you guys. Probably because I saw the 1 above it. It's got to be a cube, right? So 1 times 1 times 1 is 1. So that one's kind of silly. All right, so we've written it as something cubed minus something cubed. So on our difference of cubes formula, we can write it as something cubed minus something cubed. And this is the formula that we're going to use. Same sign, opposite sign, and always positive, always plus. Now, in this case, our a would be 3x, and our b would be 1. So we're going to go in here, equals. All right, a minus b, so we're right here. A minus b. A squared, be careful that you use parentheses, otherwise you'll get it wrong. A squared plus ab plus b squared. If you don't use the parentheses, you might forget to square the 3, you guys. So you've got to make sure that this 3 gets squared here when you proceed to simplify a little bit more. So this is actually going to become 9x squared. And then when we multiply those, we're just going to get 3x. And 1 times 1 is still 1. There's our answer. So go ahead and take a second to try one on your own, see how you're doing. You know, are you able to find the a and the b? Once you plug it in, are you able to simplify and get to the very end, to the final answer? Okay, so let me go ahead and, well, we'll start, we have to write it as something cubed minus something cubed. Well, 4 to the third is 64. And 2 to the third is 8. So that's going to be our rewrite in the form of a cubed minus b cubed. All right, so same sign, opposite sign, always positive. Let's go ahead and, oops, let's say what a is. A is 4x and b is 2. Okay, so let's go ahead and substitute it in. A minus b, 4x minus 2, a squared. Oops, I'm already writing 16, guys. All right, 4x squared minus ab plus b squared. All right, so 4x times 4x will just be 16x squared. And then 4x times 2 will be 8x. And then 2 times 2 is 4. So hopefully those of you that were trying it on your own at home, hopefully you did pretty well. Okay. All right. Let's apply this to one of the logarithm problems from your text. All right. So we got to express this as a single logarithm and simplify if possible. So remember that with logarithms, subtraction really means division. So we're going to condense these 2 logs into a single log, but we're going to write them as a quotient. We're going to divide them, in other words. Now, it will probably, I don't know where the 1 came from, you guys. How about an 8? There we go. So this will, they'll mark you off for this because it says simplify. And so this is where that difference of cubes thing comes in, right? If we take x cubed minus 8, we can write that as x cubed minus 2 cubed. So if we use the formula for a cubed minus b cubed, same sign, opposite sign, oops, always plus. our A would be x and our B would be 2. So we just have to substitute it into the right-hand side. So this will become x minus 2. A squared will become x squared plus A times B plus B squared, so 2 times 2. All right, so 2 times x is going to get us 2x, and 2 times 2 is going to get us 4. So that's what we're going to substitute in for the top. X cubed minus 8 is really this. And now you can probably see why they would have marked you off if you had left it like that. You didn't technically simplify the x minus 2's. So then we actually get not even a fraction anymore. We get this kind of nice polynomial here. So these difference of cubes, sum of cubes are going to sneak up every now and then throughout the class, and definitely in the future if you're going to proceed on. So it's very important that we actually know this. Okay, I want to say this is our last example. Okay. All right. So it says find log base B of 21, knowing all of these logs up here. So this is kind of a common type of problem they like to give to make sure you know your properties. You can't use your calculator because they didn't give you the base, right? So it's not like you could use the calculator to do it. Okay, so what we're going to do is we're going to rewrite the 21. And now it's like, okay, I can rewrite them a lot of ways. But maybe you're noticing up here in the top that they gave you a 3 and a 7. And that's kind of nice because 21 is 3 times 7, right? So we're going to go ahead and rewrite the 21 as 3 times 7. And the reason why we might want to do that is because we know that multiplication splits into addition. All right, so we know log base B of 3. According to the directions, log base B of 3 is 0.6826. We also know log base B of 7. According to the directions, log base B of 7 is 1.2091. Let me write that 0 a little better, you guys. 1.2091. So we just have to add these together and we've got it. Okay. Oh my goodness, can I add? 1 plus 6 is 7. 9 plus 2 is 11, carry the 1. 0 plus 8 is 8, but I carried a 1, so it's 9. I think it's that. You might want to double check me with your calculator. I don't know why I just didn't use my calculator. Let me make sure because I don't want to have the wrong thing here. Okay, so 0.6826 plus 1.2091. Yeah, looks good. Okay. All right. Let's try the next one. Now, I'm going to do the next one differently, even though we could do it exactly the same, but I don't want to bore you to death, you know? Sure, I could write the 9 as 3 times 3, but I'm actually going to write the 9 as 3 squared, so I force us to use a different property. So instead of using the product property, I'm going to use the power property just to keep things interesting and make us use something different. So the 2 will pull out front, and we got log base B of 3. So 2 is multiplying by log base B of 3, and log base B of 3 is up here in the directions, so it's 0.6826. So if we multiply 0.6826, 0.6826 times 2, 1.3652. Okay. All right, last one. We know that division becomes subtraction. So we're going to do log base B of 7 minus log base B of 2. And we're going to fill those in. Log base B of 7 is given to us in the directions. And log base B of 2. So I'm going to consult my calculator for this. 1.2091 minus, I can't type the right thing right now, 1.2091 minus 0.4307. All right, I'm getting 7.7784, you guys. Hopefully that matches what you have. I always have my students in the classroom there to check me, you know, and be like, nah, Mecklenburg, you punched in wrong. So it feels weird when I'm doing Zoom because nobody's there to be like, you messed up. I had students tell me, like, watching the videos, and they're like, oh, she messed up there, but they can't tell me, you know. So hopefully this looks good. I tend to mess up when I have decimals and stuff, but you guys get the gist, okay? All right, you guys. Thank you so much for joining me, and best of luck on this section. Take care.